Another good, tough problem. Curve sketching. But maybe with only the shape of curves. We're not worried so much about, zeros and other things yet. Anyway, we have f of x. We're going to find f prime of x, then we're going to find f double prime. Okay? So, as always, we let f prime of x equal 0. Right? Well, this is going to be low d high minus high d low all over low squared. Okay? Maybe we could simplify this a little bit before letting it equal 0. So maybe I'll erase this for right now, simplify it a little bit. Let's see what we're getting here. We're getting 2x cubed plus 8x minus 2x cubed plus 8x. So it looks like we're getting 16x over x squared plus 4 quantity squared. I think actually we can sneak this up here, and we'll let that equal 0. So I think that's pretty clear that the function equals 0 at x equals 0. Also worth noting that the bottom never equals 0, so we're clear on that front. Okay? Now, jump right into the second derivative. All right, now this is a little bit more involved. Let's see why, right? We're going to have low d high minus high d low. Right, now that's going to be chain rule going on here. All over low squared. So x squared plus 4 squared is going to be to the 4th, right? We're going to let this equal 0, okay? But again, maybe let's simplify it a little bit first. So when we simplify it, first of all, note that we can knock off a factor of x squared plus 4. That's a nice thing we can do. And we don't need to worry about like dividing by 0 or something, because remember, that can never equal 0. So when we multiply it out, we're going to get 16x squared plus 64 minus, that's going to be 64 x squared. Looks like we're getting. Yeah. All over x squared plus 4 cubed. All right, and maybe we can let that equal 0. Actually, before we do that, let's try to simplify it even a little bit more than that. Let's pull out a factor of 16. And we're going to get x squared. Oh, no, you know what? Never mind. Notice we've got x squared terms here, right? Here and here, so we can combine those. So we're going to get, we'll still factor out the 16. I think that's a good idea. But maybe we'll get, I guess, 4 minus 3x squared. Yeah, I think that's what we're getting here. And then at the bottom, it's, of course, x squared plus 4 quantity cubed. And let that equal 0, okay? Now, if you notice, the bottom never equaling 0, so we're worried only about the top, the numerator. So just to show you, we have, pulling out the 16, maybe that's confusing to do the whole big print. We can just factor it out at the top, right? If the brackets are a little weird, then we can just do it like this. That confuses you, okay? So do 16 times 2 plus root 3x times 2 minus root 3x all over x squared plus 4 cubed equals 0. So x equals plus or minus 2 over root 3, and if you'd prefer to rationalize your denominator, that's 2 root 3 over 3. Okay? It's a little bit more than 1, right? Root 3 is like 1.6 or something like that. Okay, 1.5-ish, 1.6-ish. So 2 divided by this is like 1 and a third or something. Okay, anyway. When we do our chart, we're going to have, let's see, x equals 0 up here, and then we have x equals negative 2 root 3 over 3, and positive 2 root 3 over 3 over here. Okay? So let's see what happens. We plug in a negative number. It should be pretty clear that this value is negative, because the top is negative and the bottom is always positive. Plug in a positive number, you're going to get a positive number. Okay? Now let's see what happens with the second derivative, right? Be a little more careful. Plug in a negative number, like negative 10 or something. Top is clearly going to be negative. Bottom is always going to be positive, right? Always, 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 because you're squaring the number and then adding 4 and then cubing it, right? So we have negative here. Plugging in, I don't know, 0. We're getting positive there, and then you plug in another big number and you get a negative. So, f is, we should write this increasing on 0 to infinity and decreasing on infinity to 0. F is concave up on negative 2 root 3 over 3 to positive 2 root 3 over 3, and concave down on everywhere else, right? Negative infinity to negative 2 root 3 over 3, union 2 root 3 over 3 to positive infinity. Also, I'm just going to say this. I'm writing it out. Maybe I'll write it down. Okay. F has critical point 0, comma, was that negative 1? And local min f of 0 equals negative 1. F has inflection points negative 2 root 3 over 3, comma, let's see what happens when you plug them in here. You're squaring them. So it's 4/3 minus 4 over 4/3 plus 4. So you're getting negative 8/3 over 16/3. So I think that's negative 1/2. So that's going to be what you get in both cases, actually. Plus minus the right there. Okay. So your graph, as best we can sketch it, is going to look something like this. We know that 0, negative 1 is, that's a minimum. It looks like you might think we're doing something like this. Actually, we do know that we also have these points. We got these points. We know that negative 1/2 is the other place that's important. So let me sketch this in purple. So I guess we have something like this. We know that this point exists. That point exists. So our graph look something like this. Well, one sec. It's coming down like this. Then it sort of does that. Then it comes back up like this, and then starts to do that. Okay? Now, it's possible, I suppose, that the graph maybe does something more like this. In fact, it does. Actually, if we're going to be a little more careful, it actually does something like this, as it turns out. To do that, try to look at the horizontal asymptote, right? Limit as x approaches infinity or negative infinity. Okay? But this is a tricky graph. Okay? Again, a little bit longer than I'd ask for on an exam or a quiz, but definitely a good one to practice. Thanks for watching.